Productivity is always output over input, some form of output over input. So calculating so-called simple productivity measures, where it's just an output over an input, is really just a question of spotting which is the output and which is the input. This particular question here is a really good example of that. In a machine shop, 6 employees repaired 45 engines in a 5-day work week. What is the productivity of the machine shop? That's described. Okay, output over input. I just have to spot which is the output. Well, let's see, what's the actual product here? Looks like they are repairing engines. So 45 engines over what's the input. Now here I do need to be kind of careful in that it looks like I'm told 2 different things, but they're related. I'm told about 6 employees and they're working a 5-day work week. So the most relevant way to wrap up that information is it doesn't matter how long they worked. Okay, 6 employees over 5 days is employee days. But to answer the question, it's really this ratio of 45 divided by, okay, 6 times 5 is 30, 45 divided by 30. Okay, 45 divided by 30 on your calculator is 1.5. That is the productivity reading. You can kind of illuminate it. You can say it's 1.5 engines per employee day. That would be a good way to describe the productivity of the machine shop, 1.5 engines per employee day. Now, that particular problem is also what we would call a labor partial measure or labor productivity, because the denominator was employees. That particular problem with the engines didn't mention labor productivity, but the next problem does. It mentions it by name. 5 customs and immigrations officers work 7 hours each to check visas and stamp passports for 673 arriving visitors at an airport terminal. What is the, see, it's being asked for by name, labor productivity of this group of 5 officers. All right, now, different context. Oh, specifically labor productivity, certain sense doesn't matter. There's an output and there's an input. You just have to identify them. Okay, well, what's the product here? It's a service. They are checking visas and stamping passports for 673 arriving visitors, right? Then what is the input? Well, labor. In this case, there's a tip. Look for how much labor, right, to process 673 visitors at the airport terminal. It's 5, that does matter, officers, and they worked 7 hours each. So that is 35 labor hours. But the actual labor productivity reading is the 673 divided by the 35. Okay, 673 divided by 35, I get 19.23. That's the labor productivity reading itself. Although it has meaning, you can interpret it or articulate it. It is 19.23 visitors per officer labor hour. 19.23 visitors per officer hour. The next question is also a labor productivity question. So it's going to follow that same template. There's going to be something, some kind of product in the numerator, and there's going to be labor hours in the denominator. What does it say? 8 part-time workers at an airline catering facility prepared 2,010 meals. There's your output. 2,010 meals in 6 hours. What is the, right, and it's asking by name for the labor productivity. So we just need the labor hours in the denominator. There are, in this case, 8 part-time employees. They're working 6 hours each. So the denominator, 6 times 8 is 48. So we would want to say 2010 divided by 48. I get 41.875. That's the labor productivity measure. Although, again, it has meaning. What is that? That is meals per part-time labor hour, because that's what the denominator was part-time labor hours.